Getting started today, guys. The whole idea of congruent figures is where we're going to get started today. We're focusing on triangles, and I need to make this clear, guys. We're going to be doing a lot with triangles. I can't stress this enough. This is not like we're going to do one day with this stuff. We're not even doing one chapter. We do several chapters just on things with triangles. We prove them congruent. We prove them similar. We deal with trig formulas in them. We deal with all kinds of things like area with them. Triangles are going to be something we focus on a lot, maybe too much. Guys, triangles, triangles, triangles. This is the beginning of this idea. We're starting with these congruent figures and we're focusing on triangles. So, getting started. In order to have congruent triangles, first of all, they must be triangles, so they're going to be triangles. Oh, I apologize. Here we go. Thank you for saying something. I thought I got to clear it. My button didn't connect. They are going to be triangles that have, and this word is going to be everything in this set of notes. This word is big. Corresponding parts congruent. Corresponding parts congruent. Okay. Corresponding. If you're comparing things that are in the same location, then things are going to be corresponding. For example, if you look down here at this triangle, do you see this A is up in the top left corner? It's got one mark on it. You look over here on this triangle, it's in the top left-hand corner. It's got one mark on it. Those would be corresponding angles. They're in the same location of the triangle. Okay, they match up. If all 6 parts match up with all 6 parts of the triangles, then you are going to have congruent triangles. But it takes 6. Guys, listen to me. I do something. You need to know this. It takes 6 parts. 6 parts. Why are there 6? There's 3 angles and 3 sides. Lines, whatever you want to call it. 3 sides. Okay? You have 3 angles, 3 sides. That's 6 parts that have to match up. Angle A would have to match up with P. C down here would have to match up with Q. The side AB has to be congruent to the side PR. Everything has to match up and be congruent. So I'm going to say it one more time. In order for them to be congruent, all 6 parts have to match all 6 parts. That's the definition of congruent triangles. If all 6 parts, all corresponding parts match up with all corresponding parts, and they're congruent, the triangles will be congruent. We're going to use this definition later on, definition of congruent triangles later on in a proof. So you've got to know this definition is going to be something you use. Okay? Okay, guys, here we go. The next thing. The problem is when they show you pictures, guess what? They're not going to show them to you where they're just right beside each other and perfect. They're going to do what we call transformations to them. They're going to first slide them. Okay? So if I ask you, if I look at these triangles, these are congruent triangles. They match up with each other. Okay? In these congruent triangles, what angle is going to match up with angle C in this picture? N's going to go with C. Okay? What if I said what matches up with M? B. Good. So you're able to see it when it slides. Let's take it when they turn and rotate it. If they turn and rotate it, what angle matches up with angle Z? Z goes with, I think it's a Q, isn't it?
That is a Q.
Okay, I'm just making sure. I was just making sure I didn't see it wrong. Z would match up with Q. How do you tell, guys? Because look, here's a mark. Here's a mark. All they did was take it and turn it up on its little end. Okay? What if I said the side X, Y? You got to go in that order, guys. X, Y. What matches up with X, Y? PR. Perfect. That's correspondence. That's things being in the same location, even though they might twist them, rotate them, do what they do. It can also happen when you flip. What's going to be in the same location if we've got X right here, okay, and we flip it over to this triangle? What's going to be the same as angle X? P. Good. No issues there. What about if I say segment YX? YX. What would that go with? Segment what? Q. Good. Y'all are seeing correspondence. That's wonderful. They match up with each other. They go in the same order. Okay. Anybody just have any question about the idea that just because the pictures aren't facing the exact same direction doesn't mean the parts don't match up? That's all we're talking about. Yep. After we get done with notes. Yeah, let's get done with notes first. Okay. Good. Okay, here we go, guys. The next thing that you're going to have to use as a word or reason in your proofs, third angle theorem. This is a very convenient theorem. Guys, it says that if two triangles are congruent, they tell us these two triangles are congruent, and you know two angles are right here that are the same, then the third angle has to be the same. This B would have to be the same as R. Angle B would have to be the same as angle R.
Angle P?
B. Right down here. See, it's written at the bottom. B. It's already on your paper. Yeah, it's okay. Again, the reason is that the two are going to be congruent to the other two. And let's just do the math real quick. Let's say this one's 40. That means this one's got to be 40. This one's 50. That means this one's going to have to be 50. Guys, do the math. What's 40 plus 50? 90. And if you do 180 minus 90, it's going to leave you 90. And if it's 90 for this one, it's going to have to be 90 for this one. Now, you don't need the math for that. I'm just showing you that the math is going to work, because if these two are the same, then the math's going to be the same when you add them together and subtract from 180. So the concept that you're supposed to get out of that is if you know two angles, then you also know that the third angle is going to be the same. If you know two angles are already the same, then the third one's got to be the same. It's called third angle theorem. So far, so good?
How do you say that word?
Third angle theorem. Theorem, yeah. It's a good question. It gets worse as you go through the day when you say it a bunch of times. Okay, guys, congruent statements. You're going to have to do this on your homework. This is like problem numbers 4 through 7. 4 through 7 are just like these. Okay? Huh? Yeah, absolutely. So 4 through 7. On problem numbers 4 through 7, watch your folder just so it doesn't hit her in the back. It's okay. She just didn't know because she wasn't sitting there before. Okay. You're going to have to be able to tell me all the sides that are the same and all the angles that are the same. We'll start with the sides. So the sides are going to be segments that are congruent to each other. So I'm going to go ahead before I do anything and set up this little thing, because it's going to be three sides congruent to three sides. So I'm going to name my first side. I'm going to go from A down to B. And if I go from A down to B, what does it have to match up with in my other one? It's the matching that matters. PR, perfect. No issues there. PR. And if I go from B to C, what's it going to be for the other one? RQ, perfect. There you go. For the next one, if I go, and I'm going out of order on purpose, guys. If I go from C to A, then what have I got to do on the other one? Q to P. Perfect. Concerns, questions, anything about the segments? Okay, how many parts do we have congruent so far? 3. We've done all the sides. What else do we need to do? The 3 angles. Here we go. I need 3 more angles. I need 6 total parts congruent to 6 total parts. So I'm going to go through and put my angle symbols, all of them, put my congruency symbols so that I don't have to worry about that while I'm trying to figure out what matches up with what. I've already got that written. I'm just filling in. Okay, based on the markings, guys, look in here. Look at this picture. See, it's got 1 mark here on the A. So what does A match up with in the other picture with 1 mark? P. Perfect. See, the C right down here is going to have 2 marks on it. So the C is going to match up with what? Q. Did you do B next? Did you do B next? I did, but I did it out of order on purpose. So if you look at B, now listen. How do you know that B is going to be the same as R?
It doesn't have a line.
It doesn't, right, but that's not the reason. It doesn't have a
Oh,
mark,
it's
that's
final
true. But what's the theorem that says that if I have two the same, then say it, just say it. Third angle theorem. Third angle theorem tells me that if I've got two the same, then the third one has to be the same, so B would be congruent to R. Now, those are the congruency statements for the angles. They're going to ask you about that. And these sides, they're going to ask you about that. But there's one other type of congruency statement that's going to be more important for the whole chapter. You do this all chapter long. And that is what's called a triangle congruent statement. If you write that one triangle is congruent to another triangle, and you name it, you've got to name it so that they match. Now, I'm doing this out of order on purpose, guys. Listen to me. I'm doing this out of order. I'm going to say B, C, A. I'm going to go from B, I'm going to go down to C, and then I'm going to go back up to A. I'm going B, C, A. Let me change colors. I don't like that. Let me do it in red. B, C, and then to A. If I go B, C, A, what would I have to do for this one?
R, Q, P.
Perfect. R, Q, P. Do you see I'm going from R, going to Q, then going up to P. I'm just matching the order. Any questions about the correspondence, the order matching up? Okay. Did I have to say BCA? No, it could have been anything. But whatever the first one is, you have to match it on the second one. If I said ABC, what would the second one be? PRQ. Perfect. PRQ. Nice. Nice. All right. Corresponding parts must be listed in the same order. Meaning if you match them up, they've got to be corresponding. They've got to go in the order that they match. Okay, guys. Let's go to the next one. Oh, is that on the back? Have we flipped to the back? Okay, here we go. Good. All right. Identify all the corresponding parts and write a congruent statement. So they just told you. Corresponding parts, that's all the sides and angles. And then congruent statement is going to be the final triangle congruent to a triangle. Okay? Why is this one different? Because you see they took and they rotated it. So you have to look at it a little bit more closely. So we'll start off with the sides. Side, side, side. Side, side, side. I recommend you write that down first. Ooh, sorry guys. That you write that down first. Put your congruency symbols in the middle. Right. If I go from W to X, that W to the Y, I'll get my letters to come out. I'm going from the one that has 2 marks on the angle down to the one that has the right angle. So if I go from 2 down to the right angle, what would it be on the other side? Q. Wait a minute. From the 2 to the right angle. 2 marks to there. So it should be. Look right here. See these 2 marks?
Oh, yeah.
I'm looking for these 2 marks over here. See, it's where the Q is. And then I'm going down to the right angle. So it's going to be Q. You're good. Q and P. Is that better?
I was looking at my.
Or you look at, I apologize, yeah, it's just the order, it's the way, I apologize about the, for some reason, our new printer prints the slides from left to right, or right to left, and they can't figure out how to switch it. So that's my fault, it's just the printer and I can't change it right now. The BizHub or whatever we've got right now that's doing it, it's a big fancy printer, but they can't figure out how to print them on the right side. Okay guys, here we go. If I go YX, I'm going from the right angle symbol to nothing. What would that be on the other one? Right angle symbol to nothing would be PR. Where's the right angle symbol? Do you see this right angle symbol right here? See that? I'm going from that to where there's nothing. So I'm going from here to here, which is from P to R. Okay, my last one. Let's say I go W to X. If I go WX, That's from 2 marks right here down to nothing. So what would that be on this side? QR. From the 2 marks here down to the one that doesn't have anything. Questions, concerns, anything on the sides? Okay. Okay, angles, guys, here we go. Angle, 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 angle. Put your little congruency symbol in the middle. Guys, don't think this take a long time. Write it quick, get it down. I'm just going to go ahead and list my angles. W, Y, and X. Okay, W has 2 marks on it. What angle in the other one has 2 marks on it? Q. The angles are the easy part, guys. The Y has the right angle symbol. What angle has the right angle symbol? P. The X has no mark. What angle has no mark? R. That's it for the angles. Now the triangle congruency statement, guys, it doesn't matter what order you go in, they just have to match each other. So if I go in the traditional way on this first one and I go from W to Y to X, WYX, I'm going from 2 marks to the right angle symbol to nothing. So I'm going to start at the 2 marks, go to the right angle symbol, and then go to nothing. What order is that going to be? QPR. Y'all aren't having any problems with the order. That's awesome. Overall, I mean, I know some people are going to still have questions, but overall, that's great. Okay, guys. Any questions so far before we move on to the next thing? No? Okay, guys, here we go. So the last part of this and then the proofs, the last part of this part is going to be the algebra. This is just matching things up, guys. All you're doing is matching things up based on the congruency statement. The W matches up with the P. So if this W is right here, it's going to be the same as the P. So if this one's 79, this one's going to be 79. The Y right here is in the middle, so the Q is in the middle. So whatever the Y is right here, which is 78, the Q over here is also going to be 78. So guys, y'all see you've got your first equation. 3y plus 6 is going to be equal to 78. Pretty straightforward. If we look at the sides, because guys, look where your x is. This is what we're trying to find something to match up with. The 2x minus 1 is between w and x. W and x are the first one and the last one up here. Okay? That's going to match up with the first and last one up here, which is going to be P and R. So do you see that the 2x minus 1 is going to match up with the 24? Now, solving them, I don't think is the problem. This seems to be, once y'all, if you can get it set up, this is the geometry is setting it up. The algebra part, especially on two-step equations, y'all tend to do very well on. Plus 1 plus 1, it's going to be 2x is equal to 25. Divide by 2, divide by 2. Do 25 divided by 2. You can leave it as 25 over 2, just so you know. I would take that as an answer. But it's also a decimal. It's like, is it 12 and a half, 12.5, however you want to write that? Yep. For the other one, again, the solving part is not my biggest concern. I think this part you do well at. 3y is then equal to 72. Divide by 3, divide by 3, and y equals, what is 72 divided by 3? 24. Thank you, 24. Does anybody have a concern of anything that I've done on this one before we move on? Because the next one's weird. I'm warning you ahead of time. They draw it weird on purpose. I don't even think there's one like this on the homework. I put this on here because the EOC likes to do what's on this next problem. Yes?
Alright, so they said x equals 12.5.
Yep.
Would you rather take that as a decimal?
I don't care how you give it to me. It can be 25 over 2, 12 and 1/2, or 12.5. In geometry class, I'll take it any 3 of those ways. In algebra, I require them to be in proper fractions because we factor and do other things with them, so you can't use a decimal. Can't use a decimal for slope, can't use a decimal for a lot of things, guys, but for geometry, I'll take it any of those ways. It's a good question. Anybody else? Okay. Last one of these, and it's weird on purpose, guys. This is weird. They tell you at the beginning of your EOC that pictures are not drawn to scale. Pictures are not drawn to scale. If you look at this picture, I would think that this 60-degree angle right here would match up with this R, right? The way it looks. That this little angle here, 30, matches up with that P. Guess what? They don't.
Oh.
They don't.
It's
It's messed up on purpose. You have to follow the congruency statement. Watch. Look right here, guys.
Oh, that's.
Yeah, that's very irritating. W, right here, matches up with P. Does this look like a 60-degree angle? No. Could be, because they're not drawing it to scale. They don't tell you it's drawn the right way. They tell you that it's specifically that it might not be the right way. This 90 right here, the Y, does match up with the 90 right here on the Q. So this one is going to be 90. There's our first one. 4Y plus 2 equals 90. That part's not too bad. And then the last one, the X matches up with the R, so the 30 matches up over here, and this is 30. What? Wait. What is your question?
Where did you get 90 from?
Where did I get the 90 from? The Y right here is 90. So because the Y is 90 and it's in the middle right here, the Q is in the middle over here, so it's also got to be 90. Okay. It's like a sketch on Stooges. Okay, here we go. The next one is going to be dealing with figuring out what matches up with this. Guys, look, I'm going from Y right here to X right here to find this piece right here. I'm going from the 90-degree angle to the 30-degree angle. You see it goes from here at the 90-degree angle to the 30-degree angle over here. It's going to match up with the 8. What would you have said if you didn't know to look at it? I would have said 14. But they're telling you it's not drawn to scale. So you would set the 3x minus 1 equal to the 8. They're tricky in geometry. Okay, here we go. Again, the solving part is not my part I'm concerned about. Y'all seem to be doing very well with your algebra equations overall. Plus 1 plus 1. Divide by 3, and x equals 3. Minus 2 on this next one. It'd be 4y equals 88. Divide by 4, and y would equal 22. Okay. Now, on this test, you will be writing your own proofs from scratch completely. Now, will most of them be the same exact pattern? Yes, because the only thing we're doing this chapter, guys, this whole chapter, is proving triangles congruent. That's it. So they're all based on the exact same concept. The first type will be like this one. Based on the definition of congruent triangles, all 6 parts have to be congruent to all 6 parts. So we're going to start off by talking about the different parts. Let's start with the sides. Look at your picture. Oh wait, before I even start that, just because some people, they see it much better when I do this. This is what we're trying to prove, guys. We're trying to prove that triangle WXY, that's going to be WXY, that's this triangle right here, is going to be congruent to triangle WZY, which would be W, Z, and Y. Do you see those two triangles are next to each other? Okay. So now that we've got that, let me trace that one again. I just want to be right on top of it. Right there. Okay. So now that we've got those two triangles, we're going to name the parts in those triangles that are marked congruent. Because if they're marked congruent, they're telling you already. That's given to you in the picture. So the parts at the top. If I say segment XW is congruent to segment, now guys, XW, I went from here to here. What's it going to be on the other side going in that same order? Okay, I went in. XW goes in, so I got to go in, so it's got to be ZW. The order matters, guys. Order matters. Okay. How do I know that? Because in the picture it was given to us. Guys, if they mark it, they've given you that answer. Alright, let's do the next segment. What if I say my next segment is going to go down on this outside and go down out here, and it'd be XY. Segment XY. If I'm talking about segment XY, what's it going to be congruent to on the other side?
ZY.
Perfect. No issues there. ZY. Why? If it was marked, what do we write down? Given. It's that simple. There is a third side here. Now this one, guys, do you see where the purple line and the green line are overlapping each other? That means that that side is congruent to itself. So WY is congruent to WY, and we have a property for that. What property says something is congruent to itself?
Is it reflexive?
Yes, it is. Reflexive. Reflexive property of congruence. Now let me tell you, that's going to show up all chapter, guys, so that's one you got to know. You put this anytime something is congruent to itself. Now guys, what have we done? We've proven that all three what are congruent to all three what? Say it. All the sides. All three sides are congruent to all three sides. That's exactly right. So if we've done all three of the sides, what do we need to do for the next three steps? The angles. We need to do the angles. 4, 5, and 6 are just going to be proving the angles congruent. Alright? So let's start with the easiest angle. Guys, the angle that's marked out here is the easiest angle. Angle X is going to be congruent to angle what? C. How do we know that? What do we write down, guys? Given. If it's marked, we write given. Okay, guys. The next one that we know. Do y'all see this is a line that's got one right angle? If you have one right angle, then you're actually going to always have two right angles. Now, this angle's different, though, because you can't name it by one letter. You can't say angle W is congruent to angle W, because what angle are you talking about? You got to name it by 3 letters. This is how you do it. You go X, W, Y. That's this angle on this side. Angle X, W, Y. If I went in and then down, what would I do to name the other one going in and then down? Z, W, Y. Notice W is the middle letter on both of them because that's where the right angle is. Wherever the angle is, that's the middle letter. And what's the reason? It was given in the picture. They had the right angle symbol there already, so you know both of them got to be right. Okay, the last one is going to be the angle down there at the bottom. This angle has got to be congruent to this angle. So before we think about the Y, let's name it. If I name this angle, and I'm going to go down and then up, down and then up. So I'm going to go down on the outside, then back up again. So it's going to go X, Y, and W. Congruent to, it goes down and then up. What would it be on the other side? ZYW. Very nicely done. ZYW. Now the reason is not the same, guys. Those weren't marked. I marked them congruent. But how did I know they were congruent? It's in the stuff we've learned today. Third angle theorem. We already knew 2 angles were the same. If we know 2 angles are the same, then the third one has to be the same. It is called third angle theorem. You can write out the words or the acceptable abbreviations, which we've talked about as we go. Guys, we proved all the sides congruent and all the angles. If all the sides are the same and all the angles are the same, then the triangles are the same. Guys, you already have the statement. It's already right here. We already have what we're trying to write down as our statement here. Triangle WXY, the green one, is congruent to triangle WZY, which is the purple one. And why do we know that? What tells us that if all 6 parts are congruent to all 6 parts, the triangles are going to be congruent? It's on your sheet. Huh? There it is. Definition of congruent triangles. Definition of congruent triangles. Listen, guys. Definition of congruent triangle says if all 6 parts match up with all 6 parts, if the corresponding parts are congruent, then the triangles are the same. So you've got 3 sides and 3 angles, therefore they're congruent.
Did you, explain number six again?
No, say it one more time, I'm sorry.
Can you explain six again?
Absolutely. So when you look at this, let me get to a highlighting color that will show up over the top of the other ones. So let me get there first. Alright, you see you got this angle right here, congruent to this angle right here. You see you've got this one congruent to this one. If you have 2 angles congruent to 2 other angles, then the third angle must be the same. Third angle theorem. That's why this one's congruent to this one. Anybody else? Okay, guys, that's your notes today. Let's get you working on your assignments. I do want to talk about one